This is your day 3 notes over limits. Continuity of a point. A function f is continuous at x equals c if all of the following are satisfied. The first condition is f of c must be defined. The limit as x approaches c of f of x should exist, and the limit as x approaches c of f of x must be equal to f of c. 2 and 3 are kind of together because if it's equal to f of c, that means it exists. Remember, all of them must be not only one, but all of the following must be satisfied. Now let's figure out why the following functions are not continuous at c. The first one, at x equals c, I can tell you that f of c is not defined because I have a hole there. So f of c is undefined. The simple fact that it's undefined makes it not continuous. This is not continuous because the limit at x approaches c of f of x in this specific case does not exist. I would say does not exist. We usually put DNE. For the last one, I can say that the limit at x approaches c of f of x, this time it does exist, but it's not equal to f of c. Because f of c is here, and the limit is at this little open dot. One side's limit. The limit of f of x as x approaches c is L. If and only if the limit of f of x at x approaches c from the left is equal to L and from the right is equal to L. I mentioned this before. Alright, remember the negative here means left and the positive there means right. Let's look at the graph we have here. For graph B above, the limit as x approaches c from the left of f of x and the limit of x approaches c from the right of f of x have different value. Hence, the limit of f of x as x approaches c does not exist. Alright, let's go ahead and look at this. For A, find limits as x approaches 1 from the left, meaning it's approaching 1 from the left. In other words, it's traveling from the left and approaching 1. The limit seems to be at this point, so this is equal to -2. If you do the same thing, this time approaching it from the right will be traveling on this, and that limit seems to be at this point, which is at 1. But these two are different, therefore the limit at x approaches 1, not from the left or from the right, just as x approaches 1 of f of x does not exist because these two are different. Graph each function. Find the limits as x approaches c from the left, from the right, and determine if each function is continuous. If it's not continuous, state where it is not continuous and describe why using the definition of continuity. The first function is f of x equal absolute value of x over x at c equals 0. Obviously, c equals 0 cannot be plugged in, but if you want to graph this function, and we graphed this before, by the way, at -1, you will have a hole here, and it will make a straight line. You will have another hole here, and you will make a straight line. For me, let's start with A. For A, I will say the limit as x approaches 0 from the left of f of x is equal to, from the left, it will be -1. And let's do B. The limit at x approaches 0 from the right of f of x. This means from this side, it will be 1. Based on these two, I will say it's not continuous. And because it's not continuous, where we're talking about at x equals 0. Why? Because f of 0 is just not defined. On top of this, although f of 0 is not, this is enough for me to say that it's not continuous, I can also add this. The limit at x approaches 0 of f of x does not exist. One condition is enough for me to say it's not continuous. Let's look at problem number 2. On problem number 2, I will start with a again. But if I want to graph this one, when x is bigger than 2, so if this is 1, this is 2, bigger than 2 or equal to 2, I have a square. So 1, 2, 3, 4, 2, 4, I have a point, and it's going to do this. That's my portion of the quadratic. 2x minus 1. At x equal 2, if I plug in 2 here, I get 2 times 2, which is 4, minus 1, I get 3, meaning somewhere here. And the slope is 2. So at x equals 0, I'm at -1, it's going to give me something like this. And it's a line. In other words, I can tell already on the graph that it's not continuous. But let's go ahead and look at limits. The limit at x approaches 2 of f of x, in this case, is equal to, let's do 2 from the left. If it's, I'm going from the left, I made a little mistake here when graphing, and I'll fix it right now. The first thing that I'm doing, if I plug in 2 here, I get 4. Oh no, I didn't make a mistake. That's at 4, and it's a solid compared to an open at 3. Yep, that was correct. If I'm approaching 2 from the left, meaning from this side, I get 3. And if I'm looking now for the limit at x approaches 2 from the right of f of x, this time I get 4. Well, those two are different. By the way, this is b. Since those two are different, I can already know that not continuous at x equals 2. And the simple reason is because the limit at x approaches 2 of f of x does not exist. I'll go on and do the third one. For the third one, the first thing I will do is I'll try to graph it. X minus 1. To graph this one, if I plug in 0 here, I'm at -1. So I have a closed circle here. If I plug in 1, I'm at 0. So far, I get this line for one portion of it. And if I plug in 0, I'm again at -1. If I plug in, let's say, -1, I'm at -4, meaning it's going to do something like this. Now, let's start with A. The limit of f of x as x approaches 0 from the left. When it's approaching 0 from the left, it seems to be equal to -1. The limit now, as x approaches 0 from the right of f of x again, is equal to -1 as well. Well, so see, since those two limits are identical, I can say, let's find f of 0. F of 0 is also -1. So I will say continuous. And it's continuous because the limit as x approaches 0 from both sides is identical. And not only that, is equal to f of 0. Alright, let's go on the next one. It says use the table on your calculator for number 4 and 6 only. For 4 and 6, we're going to be using the table. And we will try to find the limit as x approaches c from the left, the limit as x approaches c from the right, and so on. So let me go ahead and get my calculator. Alright, what I did, I plugged this in my calculator on the y equal. I will go to my table set. On the table set, I want to start at 2 because we're looking around 2. And I want my table to go by 0.001, or you can put something longer here. It doesn't matter. So what I do next is I go to my table. And on my table, at 2, it shows 0. 2.001 is at 0.0017. Let's go above to see if it gets close also. they both seems to get close to 0. So on my paper, the first one, as it approaches from the left, I get 0. From the right, I get zeros also. Does the limit of f of x exist? I will say yes, and it is 0. If f of x continues, if not, why? I would say definitely continues, because these two identical is equal to f of c. So I will say yes. I'll go ahead and plug this now on my calculator. Actually, we do not need to plug this on the calculator, because it says for number 4 and 6 only. So let's go ahead and look at limits. From the left of -1, meaning I'm using the top equation. If I've used the top equation and I plug in -1, 3 times -1 is -3 plus 7 is 4. Let's do B. From the right, meaning I'm using the second equation. If I plug in -1, I get 1 plus 2, which is 3. Just looking at it, I know C is going to be a no, and D is also going to be a no, because the limit as x approaches -1 of f of x does not exist. Now let's go on to 6, and I'll put 6 on my calculator. All right, I have this equation on my calculator now. The next thing to do is go to my table set, and on my table set, I want to start around -5, so I'll plug in -5 here, and I still want to have my table going by 0.001. So I will go to my table now. On my table, around -5, I get -1.6. So let's start from the left. I get -1.6, and from the right, I get apparently 1.6. So by the way, this is the left, this is the right. The right is bigger than the number itself. So on the left side, I get 1.6. So for A, from the left, I get 1.6. But from the right, I get -1.6. Therefore, C is a no, because these two are not identical. And D also will be a no, not continuous, because the limit at x approaches -5 of f of x does not exist. 7 does not require a calculator. Let's plug in 1. If you plug in 1 into the first equation, you will probably not get it. So I will first simplify it by changing the top one into, I will cross this one and make it x minus 1 times x plus 1. And after crossing that, I'm capable of simplifying the x minus 1, leaving me just with x plus 1. Now by plugging 1 into the equation, for A, I will get 2. For B also, I will get 2, because they both follow the first equation. This is only when it's equal to 1. Now, C, I will say, for C, does limit of f of x exist? Yes, definitely. But what is the value of the limit? It is 2. Now let's look at D. Is it continuous? I would say no. Why? Because the limit as x approaches 1 from both sides is equal to 2, which is different than f of 1, because in fact f of 1 is actually 3. F of 1 is 3. So 3 is different than 2, so I can say it's not the case here. In other words, what we will get on the calculator, if you decide to graph it, you will have a line that goes through 2 here, and it will be an open circle here, but yet at 3 you will have a closed circle. We have one more problem. The last one problem says find the limit. The limit as x approaches 2 from the right. If it's approaching 2 from the right, we're somewhere below here, so I will say -3. The limit as x approaches 2 from the left will be at we say the limit at x approaches 2 from the left, it would just be 2, because it's somewhere, let's say 2 from the left, it's at 3 actually, not 2. Actually it's -2. From -2 from the right is here, and from the left is 2. I'm correct. The limit of g of x as x approaches -2 as x approaches -2 does not exist. and I would say does not exist because these two are different. The limit as x approaches 6 from the positive side will be me 4. 6 from the positive side is 4. But if I do the limit as x approaches 2 from the negative side, if it's approaching 2 from the negative side, that's a 3. The limit as x approaches 4 from the positive side, well, I cannot tell because of this situation here. So I will say does not exist. The limit as x approaches 6 from the negative side is negative 4. The limit as x approaches 0 from the positive side, well, whether it's a positive or negative side, if it's approaching 0, it remains 0. For the last one, for what value of the constant c is the function f continuous on infinity to infinity? Well, all I need is to find out what the limit gonna be. Here, in order for me to have these two identical when I plug in 3, I can say cx plus 1 is equal to cx squared minus 1. But in this case, x is 3. So that will be 3c plus 1 is equal to 9c minus 1. Subtract the 1 to get 3c is equal to 9c. By the way, it's c squared here. Divide by c to get 3 is equal to 9c. And divide by 9 to get 1/3 is equal to c. So in order for this to be continuous, c must be equal to 1/3.